So here we're going to talk about differences in longitude and differences in latitude and how you would calculate those things. But before we do that, I want to demonstrate the principles of it as if we were just talking about a normal coordinate grid like you would learn in math class. So let's say this is just an XY grid and you have 1 point here and 1 point here. And we'll say that this is position 3, 2, so 3 on the x-axis, 2 on the y-axis, both positive, and this is, 5, 7. So between these 2 points, what is its difference in terms of the y-axis? Well, you can just say, if you go straight down from this one to that one, and then compare just their y values, you would have 7 and 2, so you do 7 minus 2 equals 5, so its difference along the y-axis is 5, and then along the x-axis it would be 5 and 3, so you get 2. Simple, obvious. But what this means is that if you have two points that are in the same quadrant, all you do is you take the higher value and subtract it from the lower value, and that's how you get the difference in either vertical or horizontal. The same is true in terms of latitude and longitude. So if instead of 3, 2 and 5, 7, let's say that this is north, this is south, east, west. So we're in the northeast. So let's say that this coordinate here is 20 degrees north and 30 degrees west. And then this is, we'll just use the same numbers, 70 degrees north and 50 degrees east. Sorry, this should be east as well. So then in this case, how do we find the difference in latitude and the difference in longitude? It's the same principles. You still just subtract the higher value from the lower value. So once again, you would take, if we're talking about difference of latitude, 70 degrees minus 50 degrees gives you a difference of latitude of 70 degrees minus 20 degrees, that gives you a difference of latitude of 50 degrees. And 50 degrees minus 30 degrees gives you one of 20 degrees. So what we can say is if you're in the same hemisphere or the same quadrant of the Earth, you can just do subtraction to get differences of latitude and differences of longitude. Going back to the XY coordinate grid, and let's say we had these 2 points, we can call it 1, 8, I guess, and -1, 8. Now what do we do? Well, for the difference on the y-axis, that's easy because they're both still positive. You can still just do subtraction. So you would have 8 minus 8 equals 0. For the difference along the x-axis, though, one's negative and one's positive. So how do you find this total distance here? Well, in this case, it's very easy to see. You just add it up. But again, let's just reorient this towards latitude and longitude. You can easily say that this is, 80 degrees north, 10 degrees east, 80 degrees north, 10 degrees west. So its difference of latitude is still 0, but its difference of longitude, instead of subtracting like you did here, you're going to add them together to get a total difference of longitude of 20 degrees. Now, it's important to note that these differences of latitude and longitude don't have a sign. This isn't 50 degrees north or 50 degrees south, because you're not talking about movement in a direction. You're just saying the total distance here is 50 degrees, and the total distance here is 20 degrees. And for this one, it's 20 degrees as well. So in the last case, let's take one set of points that are completely opposite one another. So this one's in the northwest, and this one's in the southeast. You're going to do addition for both cases. So let's say, again, in XY terms, this is 2, -2. This is -2, 2. So for the y-coordinates, you would add a 2 and a -2 and get 4 total. In the x-coordinates, you would add a -2 and a 2, and you would get 4 total. Latitude and longitude, you're going to say 20 degrees north, 20 degrees west, 20 degrees south, 20 degrees east. In both cases, the difference of latitude and the difference of longitude, you still just add their total values together, ignoring the sign, ignoring which hemisphere they're on. You're just working in whole numbers. So when you break it down this way, you can see that it's not as complicated as you might at first think, because I've seen a lot of students get really caught up on this. Just because we're using a different notation system, they think that it's more complicated than it is. But it's really simple.